Hello, everyone, and thank you for joining today's webinar. This is episode 2 of a series of 3 webinars where we are getting familiar with V-Ray for Revit, its main advantages, key features, and its position in a BIM workflow. For those of you who weren't able to attend our first episode, my name is Anna. I'm architect and I'm part of the V-Ray for Revit team here at Chaos Group. As promised, for the time we had between both episodes, we released a new version of V-Ray for Revit. It is 3.7. In today's episode, we will go over a typical workflow using this latest version, and we will see what's new in it as well. And as series usually start with a short overview of the previous episode's highlights, here is a short summary I've prepared of what we've learned last time. In episode 1, we explored 5 reasons why using V-Ray for Revit is advantageous for your workflow. The well-known and super powerful V-Ray engine has been combined with a simplified UI seamlessly integrated into Revit, which saves you time and struggling with other softwares. It is very easy to use directly from within Revit, and the results are way beyond good quality. V-Ray for Revit is also very flexible. It can fit in any stage of your design process, helping you present your ideas in the best possible way, understandable for everyone. And no matter what hardware you use, it can be utilized. V-Ray for Revit offers a set of cutting-edge tools which allow you to bring your renders to the next level. Some of these tools are entirely new for the Revit world, and today you will have the opportunity to take a closer look at them. Don't be afraid to work in a team. You can easily exchange what you've rendered with your colleagues. And last but not least, you can render your project while you design it, as live geometry changes are now fully supported. In today's episode, our first and main goal is to learn step by step how from an image like this, we can achieve the following result. Before we jump into Revit, a few words about V-Ray 3.7 and what's new. Starting with full support for Revit 2019, including the new material types that were introduced there. I know this was long awaited by many of our users, and it's finally here. Live geometry updates. Interactive rendering now updates with every geometry change that you do in Revit. Add geometries, move geometries, delete geometries. Basically, every change to the Revit model will update the rendering in real time. The resolution settings window has been entirely redesigned and simplified. The same is valid for the dome light settings window. The sun and dome light settings windows have been extended with some new options. Another thing that many of our users requested, spherical panorama camera mode, and more. A full list of all fixes and new features is available on the release notes section of the V-Ray for Revit documentation page. I know some of you will notice and might get confused. Hereof, it's the time to say that behind V-Ray 3.7, we still have the V-Ray 3.6 core, which is the last one before V-Ray Next core. The changes we've made are generally new features and improvements related to the V-Ray plugin in Revit itself. And we had to decide whether to release them now or to wait until we implement V-Ray Next for Revit. We decided not to wait, as from a UX point of view, these improvements are quite important. That's why we have put them in a separate version and made them accessible for you. So let's not waste more time and dive into Revit. I will start with the well-known for everyone basic sample project, and we'll then continue with something more advanced. As you can see, my Revit version is 2019. The first thing that I have already done is to acquire my license from the Acquire License button. In case you don't want to click for a license every time when you open Revit, you need to go to Settings, Licensing, and enable the Obtain License on Startup option. Uh, when enabled, V-Ray will automatically pull its license every time you open Revit. Note that this option is not recommended for bigger architectural studios where people want to be able to share a license across multiple machines and users. A few words with regards to licensing in general. V-Ray for Revit uses an online license server. This means that you don't need any physical devices to be plugged in your machine. You only need internet connection. And even if you don't have internet all the time, there is an option to borrow your license for a short period and use it offline. At any time, you can launch the online license server in your web browser. To do so, you can either click the license server button here, or you can open your browser and type in localhost 30304. In case your license server is installed on another machine, you will need to type in the IP address of the machine instead of localhost. So here you can see your license server version, as well as a list of all your available licenses. You can click on the corresponding V-Ray product, in our case Revit, and you can see a list of all licenses that you possess. Now, going back into Revit, where the next step is to select a view for rendering from the current view button. Here you can find a list of the 3D views that already exist in the Revit project, and you need to select which one of them you would like to render. I will select the From Yard view. And at this stage, we are ready to run an initial rendering. However, I would like to focus your attention on the quality and resolution settings, as well as a few more things which is good to be set up before we start rendering. In V-Ray for Revit, there are two render modes available: production and interactive. The difference is that in interactive, you can instantly see the changes you make to the rendering. Production is suitable for a final image when all the rest of the settings have been set up. During this webinar, we will run an interactive rendering so that we can track the changes we make. And if we now move to the quality dropdown, this simple drop-down contains quality presets from draft to very high. My tip is, while you play with the settings, keep this to a lower quality, and when you are ready to render a final image, increase it to high or very high. That's why I will now keep it to draft, and we'll move on to the resolution panel. I told you that it has been redesigned and we have made it more compact and easier to use and understand. At the top, you can see the final pixel size of the image. It depends on the image size as well as on the camera mode that is used. For example, if you enable, let's open the camera settings panel. So if you enable the stereo mode for the camera, the final output will be doubled because stereo is enabled. And a tooltip here will remind you why this here is different than what you see down here. Okay, now the aspect ratio depicts the relationship between the width and the height of the image, i.e. the proportions of the image. By default, it is set to crop region so that the image you render is the same as seen through the Revit camera. A few popular presets are available in the drop-down. You can also set the aspect ratio to custom and type in any custom ratio that you would like, and you can also lock and unlock both values. If we set the aspect ratio to any of the presets, like let's say 16 by 9, here this tiny arrow becomes available, and in this drop down you can find some preset resolutions, quite common, which you can select and use directly. In my case, I will keep this to 900 by 506. The image dimensions can be specified either in pixels or in print units when the aspect ratio is set to a preset value. Yeah, I already told you that in this drop-down you can select any resolution that you want. Note that the print dimensions will update every time when you change the pixel dimensions. So for example, if I change this, the printer dimensions update as well. They depend on the DPI value. And here we have a few presets for the DPI value, which are similar to the ones we already know from Revit. If you want to play only with the printer size, well, let's say you are not quite familiar with the pixel size of an image, you can play with the printer resolution, and it is available both in inches as well as in millimeters, depending on which units you would like to print the image. Now, last but not least, before we run our rendering, as explained in the previous episode, V-Ray for Revit is very flexible in terms of hardware utilization. If you have a nice CPU, you can render using it. If your GPU is faster, you can use it instead of the CPU. Both of them can be combined in hybrid rendering as well. So how to control this from the UI? You need to open the settings window and go to the first tab, the renderer tab. And on top of this tab, here we have the engine and this toggle buttons for CPU or GPU. If you set this to GPU, the small drop down here becomes available. And here you can find a list of all your GPU devices in case you use more than one. And if you mark the C++ CPU option, this will result in hybrid rendering, which means that V-Ray will use your CPU as an additional CUDA device, i.e. the CPU will help the GPU to render the image. In our case, I would like to continue using the CPU, which is the default option, so I will select it. And now I will render. I will move the progress window to my other monitor so that it doesn't distract us. And first we will start with exploring different options for environment lighting. And in order not to be distracted by all materials, the first thing that I will do is to enable the global material overrides options. They will override the model with a simple color or a simple material. Like this. Now, V-Ray takes the sun position from Revit, and we can play with the sun while rendering. I can go to sun settings in Revit, and I can change the azimuth and altitude values to some other values. And as you can see, the sun position on the rendering has already been changed. Now, the next thing that we need to pay attention on is the exposure value. The exposure value is a number which is photography specific. It depicts the relationship between the camera shutter speed and f number. Of course, it is not necessary for you to be a photographer in order to understand how it works. It is as simple as this. The greater the value, the less light we let enter the camera, and thus the image gets darker. And this is suitable for bright daylight images that are sunny, while smaller values let more light in the camera and are suitable for interiors or night scenes. I will set up the exposure value to 13.5 for now. Later on, we will have to play with it again. And a few words regarding the white balance. It also works as in a real world physical camera. In some situations, the white color on the image might appear warmer or colder depending on the lights that are used. Starting from the white color, this actually affects all colors on the image. The white balance can help you set up the correct white color for your image to make it look natural and realistic, or you can use it for artistic effects as well. Now let's look at the sun settings, which have been extended. Uh, So we still have the sun visibility, intensity, and sun size. Those of you who have used the previous version of V-Ray for Revit are familiar with these settings. Shortly about them, sun visibility controls whether the sun is visible or not. The intensity controls the intensity of the sunlight, and the sun size controls not only the size of the sun itself, but higher values result in blurred shadows, while smaller values in sharper shadows. What we have added is some filter, which allows you to specify a hue for the sun. You can pick up any color. This updates the image. Let's take something more warmer. As you can see, this will affect the entire image. However, I would like to set the sun filter to its default value, and I would like to focus on the ground albedo options. Uh, we also have added them in version 3.7, and they're one of my favorite options because the albedo color controls the color of the ground or the color of the horizon, i.e. this gray that we see on the background, and so far it stayed always as a gray color. Now we can change it to any color we want. And of course, this allows us to change the entire atmosphere of the picture. Let's take this color and have in mind that this color will affect the GI a lot, so be careful when you choose it. Uh, Now we can also control the blend angle and the horizon offset. By default, the blend angle is set to 5.7, and let's see what happens if we start increasing it. Like, let's set it to 15, and you can see that the orange color that we have picked for the ground albedo becomes more intensive and more visible on the horizon. If we set it to 25, it is increased even more. And in my case, I want to set it to 35 so that this gradient that we see between the sky and the albedo color is visible on the background. The horizon offset works as follows. The higher the value, the lower the horizon line goes. So if I now set it to 10, you can see that this gradient that we have went a little bit down. And if I put it to 0 again, the gradient is better visible now. Another option for environment lighting is the V-Ray dome light. Let's switch to dome light. The V-Ray dome light creates an imaginary dome above the entire model. The dome can emit light either in a color or it can be also mapped with an HDR image and to emit light based on the image. This is the so-called image-based lighting. Here is how it works. After we have switched to dome light, we can change the intensity. Let's set it to 40. And as you can see, the image becomes brighter. It is now illuminated with a dome light, which is mapped with a color. We can control the color. And this affects the entire image. And now to switch to an HDR, you can simply drag and drop an HDR. I will need to navigate to my HDR image. And simply drag and drop it over the dome light panel. Here we are, here is the image, and we will have to play again with the exposure value and white balance because the image is a bit darker than expected and also a bit bluish. So I will set the exposure value to 12.5 and the white balance to a bigger value so that we can compensate this blue tint that we currently have to make the image a bit warmer. In this version of V-Ray for Revit, we have extended the dome light settings, and besides horizontal rotation, we now have a vertical shift, which allows you to shift the image vertically along the dome. Here is how rotation works. Simply use the slider until the image fits. In our case, it works best when it's set to 0, so I will turn it back. And we can offset it a little bit. You can also use these tiny buttons here on the image preview, which allow you to flip the image either horizontally or vertically. I will keep it now the way it is. And the next thing that I will do is that I will turn off the global material overrides and will start applying materials to the model. For this particular project, I have selected only materials that are available in the V-Ray for Revit material library. Uh, Here is the time to mention that all materials in the material library are in a VRMAT format, which is used also in V-Ray for Rhino and V-Ray for SketchUp. Basically, it is the same library. It can be stored on a centralized location, and no matter which V-Ray product you use, i.e. for SketchUp, Revit, or Rhino, you can use the same V-Ray materials. Now, I will add materials. It is very simple. We just need to drag and drop them. There are different categories where you can navigate and select materials. Okay, now after we have assigned the materials, we need to adjust the map sizes. Most of the materials in the library, you will notice that they contain a recommended map size in their names. However, it is not necessary to use exactly this map size. Simply use the one that fits the scale of the image and looks good. We are almost ready. I have forgotten to turn off the RPC material override, so I have just turned it off. And now we are a few more steps away from a completed rendering, just a few more settings, and it's time to replace all RPC trees with V-Ray proxies. Currently, we are unable to load proxies directly into Revit, the way it is, for example, in V-Ray for Rhino or V-Ray for SketchUp. Therefore, you need to have RPCs in the scene because they serve as stand-ins for proxies. Many users ask where to find proxy models, and I want to show you how easy you can create them on your own with the help of the Poly to VR Mesh tool. This tool comes along with the V-Ray for Revit installation, allowing you to turn any high poly model into a VRMesh file, which is the file format used by V-Ray proxies. Most users experience some difficulties at the beginning as it is command line based. Now we will run it together and see how easy it works actually. So what I have here, I have an OBJ file. Uh, I will hide the V-Ray frame buffer while we are doing this because we will not need it at this time. Here's how my OBJ file looks like. This is a screenshot taken from the 3D Studio Max. It is a tree. Now to open Poly to VRMesh, you need to navigate to your C drive, Program Files, Chaos Group, V-Ray, V-Ray for Revit, Tools. Now if you double click on the Poly to VRMesh exe, nothing will happen. We need to open a command prompt and to run Poly to VRMesh tool from it. For those of you who don't know how to run a command prompt, you need to click here and type in cmd. Here it is. Now in the command prompt, I need to type in first the name of the tool, Poly to VRMesh, space, and then simply drag and drop the obj file like this, hit space one more time. And now what I will do is that I will drag and drop it once again so that I have the same path where the obj file is saved at. And at the end, I will simply change the name. Let's name it 3a.vrmesh, and I will hit enter. At that moment, the obj is converted, and we can see that we have our 3 VRMesh file ready to use. Now I will go back to Revit, open the asset browser. I have prepared some of the proxies in advance, but I want to show you how easy the filter for proxies works. If you go to the viewport and you want to override a specific tree using a V-Ray proxy, simply click that tree, and this will activate the filter in the RPC proxies tab, and you will be able to see only that tree in the list. And now I will just drag and drop the VRMesh that we just created. What you see at that moment is totally normal because proxies are exported from different 3D platforms with different units and coordinate systems. So do not be surprised if when importing the proxy, it looks overscaled or its vertical axis is flipped. I will just decrease the scale, and I can see that the vertical axis is flipped, so I will unmark it here to straighten the tree, and it needs to be even much smaller to something like this. Initially, the proxy will appear in colors representing its material IDs, and we can drag and drop materials into both slots. Here I have my 3 materials, and I will just drag and drop them like this. Now I will deactivate the filter so that I can see the rest of the trees, which I can see that I have already overridden with another VR mesh, and I will simply enable them. Now the next thing that we need to do is to create a more realistic grass. With the help of V-Ray Fur, uh, we will create the grass. V-Ray Fur is used for rendering realistic grass as well as any kind of fluffy and shaggy objects like carpets, cushions, blankets, and so on. In V-Ray for Revit, the fur or grass is applied to a material. Therefore, if you want to cover with fur only a specific geometry in your project, make sure this geometry is assigned with a unique material. Here in the V-Ray Fur tab, we have a list of all materials that are defined in the Revit project. And we need to find the material which we want to add fur to and simply mark it, or I will just type grass in the filter and will enable the grass. Okay, now let's have a look at the V-Ray fur parameters, but for that reason I have prepared a simple scene depicting a grass field. It is a closer look of a grass field so that we can see exactly what will happen when we change the grass settings. Here is the scene that I have. It is a very simple scene, only with two materials, one for the grass and one for the earth. Opening, going to the fur tab and opening the grass parameters. Uh, so the first thing that I would like to say is that the grass is totally invisible on the viewport. It is generated only at render time. And the first three parameters control the density, length, and the thickness of the fur strands. Their values are related to Revit project units. So if you change the Revit project units, uh, these fields will also update automatically. To continue, I will use the render region so that it renders fast. And I will also decrease the density to, let's say, 350. So that we can see the grass clearly and we can see what happens when we tweak the settings. Now if we increase the length, this will result in longer strands. We can also control their thickness. Uh, Something more interesting are the next four parameters. Taper will add taper to each strand if it is set to 0, let's set it to 0, the strands will be equally thick from top to base. Obviously, this is more suitable for carpets, and as grass strands are thinner at their top, I will set it to 1. That's the maximum value. Or back to 0.9, which is the default value. The bend of the strands is controlled by the gravity and bend parameters. They stay in a relation. The gravity controls the force that pulls the strands down along the z direction. If it's set to 0, all of them will be straight. And the same is valid for the bend parameter. If we set it to 0, just like this. Now to explain the knots parameter, I will first set it to a lower value, like 2. And if we zoom in, and even if we don't, we see that the strands appear ribbed. This is because they are rendered as several connected straight segments, and their number is controlled by the knots parameter. So the higher the value of the knots parameter, the smoother the strands will be. I will set it to 4. And now they look much better. The variance option, direction variance, length, thickness, and gravity variance allow for adding variance to their corresponding parameters. 0 means that there will be no variance, while 1 is the maximal value, as in most cases strands are not equal by length, thickness, or direction. These parameters will help you add even more realism. I will keep them as they are. I will now disable the render region because I will need the entire image in order to explain how the level of detail works. I will wait for a while until it is rendered. And I will also set the density to its initial value. And the length as well. The level of detail is used in cases where we need to generate a large area of fur, just like this grass field. It conserves memory by decreasing the detail at the areas that are far away from the camera, where we basically don't need any detail. We need detail only at those areas that are closer to the camera and are well visible. So we need to set up a start distance, which is measured from the camera. And further from that distance, the level of detail will be applied by decreasing the density and increasing the thickness of the strands. And the level of detail will be applied at a certain proportion specified by the rate parameter. In our case, this means that if I set up a start distance of, let's say, 4 meters, and I set up the rate to 3 meters, this means that starting from the 4th meter from our camera, on every 3 meters, the density will be decreased 2 times and the thickness will be increased 2 times, allowing us to conserve some memory because we don't need any detail on the background. Another approach would be if you just split this topo surface into 2 parts and apply fur only to the one that is closer to the camera. Some of you will ask how the ground underneath the strands was created. Um, I would say that in some of our other V-Ray products, like in V-Ray for SketchUp or V-Ray for Rhino, you can assign different materials for the grass itself and for the ground. In this case, here in V-Ray for Revit, we still don't have this option, so I have used an additional topo surface only at the areas that are closer to my camera, and I have assigned a ground material to it so that the ground is visible between the strands. And this simple scene is also suitable for showing you how to apply camera effects. Let's open the camera settings. And the effects are located at the bottom of the V-Ray camera settings window. I will first set the focus distance to 300. This is the distance from the camera at which objects will appear in sharp focus when defocus parameter is applied. The defocus parameter simulates a bokeh effect. This means that it will blur the image, excluding the area that is at the focus distance. So if I now increase the defocus amount to something like 0.7, well, probably this is too much, but you can see that the objects that are at 3 meters from the camera remain visible. In our case, something like 0.3 or 0.4 will work okay. All right. Now, after we saw how the V-Ray grass parameters work, I will go back to the sample project for a few more things to complete our rendering. I will run the render again. And I think I would like to add some water to the foreground. This can happen by enabling the infinite ground plane, which is located in the V-Ray settings window in the environment tab. This creates an infinite plane locked at the 0 level of your project, but you can move it up or down. And I will assign a water material to it. We'll adjust the map size and the rotation. Now I think that the water is a bit darker, so what I could do is that I can click this button here that will load the V-Ray standalone material editor, and we'll open the water material into it. And I can tweak some of the settings. Save the material, and the image was supposed to update, but here I see an error message that I am not allowed to save the material to the folder that it is located right now, so I will need to save it as a separate material. I renamed it, and I can just drag and drop the preview and assign it. And now I can continue playing with the settings a little bit. And as you can see, with every change that I make to the water, the render will update. Now the last thing that I want to do is to add some color correction to the image. I will open the color corrections panel on the V-Ray frame buffer. This allows you to enhance the image after it has been rendered. And here you can control the exposure value. Here is another option to control the white balance after the image has been rendered. There are also hue and saturation options, color balance options, background image, and more. And you can set up the settings and save a preset. And in my case, I have already saved a preset which I will now load. Like this. And I think that we are ready with this image. Now we can move on to the next project that we will look at today, and probably it will be the last one for today. You have already seen it in episode 1. This model was provided by a user of ours named Dmitry Kuznetsov. Here I will show you how to use the options for sharing V-Ray settings. As it was explained in episode 1, the V-Ray settings are stored externally from the Revit file. Therefore, if you open your Revit file on another computer, the V-Ray settings will not appear there automatically. To share the V-Ray settings across users and computers, we use the Share Settings options located in the Paths and Sharing tab of the V-Ray Settings window. Here they are. From this tab, you can also configure paths to assets in cases where you have moved your assets folder to another location or you are switching to another computer. You don't need to remap everything again. Simply add the path to the new assets location under paths, and V-Ray will find the assets automatically. Now, under Share Settings, the settings which can be shared, i.e. exported or imported, are grouped into these 6 categories. You need to mark those settings which you want to export or load. The settings will be exported in an XML file. Use the export button to export them. Now, in our case, I will unmark swarm and channels settings. Uh, and I will load an XML file which I have previously exported. Here you can see all the settings that you will import, and you can exclude some of them. And as you can see, only these 4 categories were imported. Note that at this moment, the settings are only loaded in the list. To import them to the project, you need to click the import button. If you have changed your mind, you can click the clear list button and reload another XML file. In my case, I will click import, and let's render and see what we have done. Setting up the current view, render interactive. I have also saved my color correction settings in advance, so I will also load them now. And one thing that I see is that the dock in front of the building appears too bright, and I want to change its materials. And I know that the dock is actually a linked model. So what I will do is that I will go to Material Map tab, and in the Filters drop-down, I'm able to see all linked projects and to filter the materials so that the Material Map tab shows only those materials that are from the linked project. When I select Dock RVT, I have cleaned up most of the materials from it so that it is easier to be shown. And here I see that the dock materials are actually set up to a color material. I have prepared some VR mats to drag and drop over. And if you wonder how these stones here were created, they are also a VR mesh file, and we have an RPC that was replaced by a VR mesh. I can disable it just for a while to show you. All right, I think that we can now switch back to my presentation so that we can summarize what we have learned so far. Okay, with its simplified UI, V-Ray for Revit is easy to learn, easy to use, and easy to navigate. It offers different options for environment lighting. You can use the sun position from Revit or use dome light and create a picturesque background for your images. In version 3.7, you can finally change the gray color that appears on the horizon line. The library of over 550 ready-to-use materials is easy accessible and works as simple as drag and drop. It is shared between V-Ray for Revit, SketchUp, and Rhino and can be used from all these apps. Navigating around materials is easy and intuitive. Linked project materials can be overridden separately. You can add detail to your images using cutting-edge features, which are entirely new in Revit itself, like proxies and FUR. You can enhance the rendered image from within the V-Ray frame buffer using the color corrections options. If we have to summarize it in 3 words, easy, powerful, and fast. Easy to learn, easy to use, provides you with the power to express your ideas in the best possible way, and fast not only in terms of render times, but also in terms of workflow and setting setup. At that moment, the V-Ray 3.7 trial is available for all users who have previously downloaded a trial of V-Ray 3 for Revit. And if you already have a license for V-Ray 3, then you can simply update to V-Ray 3.7 for free. The build is available on the download section of our website. And since summertime is not only time for having a vacation, it appears that it is time for discounts as well. We currently have a summer promotion. There is a 25% discount on all V-Ray for Revit workstation licenses. The license includes one GUI and one render node license. And the render node license can be used not only with V-Ray for Revit, but with any V-Ray 3 application. Hurry up, as the offer is valid until 15th of July. Once again, I'm reminding you to check out our resource hub regularly, as it contains everything you need to get up and running with V-Ray, from tutorials to help documentation, past webinars, and more. We update it very often. Once again, here you can see the links to our official website, our help documentation page, and our YouTube channel. Those of you who are already V-Ray for Revit users are welcome to join our forum, where you can share tips and tricks, and why not show off some of your works. Your feedback is of a great value for us, so don't hesitate to contact us and share it. And last, if you found this webinar useful and interesting, spread around the V-Ray for Revit knowledge by sharing it with your colleagues and friends. Thank you very much for being part of the V-Ray experience, and see you in episode 3.